Good day, everyone. We are good day, everyone. We're now going to discuss the chapter three, which is the networking media. My member is Lourdine Von Catalonia, Shela Mae Daigon, and I am Ryan Bucog. I am the first reporter, and today we'll talk about the networking media. First is what is networking media? Networking media refers to the communication channels used to interconnect nodes on a computer network. Typical examples of network media include copper, coaxial cable, copper twisted pair cables, and optical fiber cables used in wired networks, and radio waves used in wireless data communications networks. In this chapter, you learn about the most common options for both cabled and wireless networking and for mobile computing, as well as where such options make sense. You find out about the kinds of transmission technologies involved in making wireless network links, where the majority of a network may be wired but interconnected using wireless links. Finally, you discover the transmission technologies that are most appropriate for users and devices that must be constantly on the move, which is what mobile computing is all about. So the first topic that I am going to discuss today um, of the part of the networking media is the general cable characteristics. All cables share certain fundamental characteristics. Studying these characteristics facilitates your understanding of their function and appropriate use. Even though wire-based or conductive cable differ radically from fiber optic cables in terms of composition and the types of signals they carry. These are the following characteristics apply equally to both types of cabling. First, the bandwidth rating. Each type of cable can transport only so much data over a given period of time. This is measured in terms of bandwidth, which describes how many bits or bytes of information a cable can carry over a unit of time. Typically, this is measured in some number of bits per second, for example, megabits per second or Mbps. Maximum segment length. The maximum segment length value falls within a range where signals can be regenerated correctly and retransmitted accurately. So, an internetwork can be constructed of several such cable segments, provided the hardware interconnecting them can capture and regenerate the incoming signal at full strength. The third one is the maximum number of segments per internet network. A network is therefore subject to a maximum number of interconnected segments simply because of the latency when signals travel from one physical end of the network to another. Next is the maximum number of devices per segment. Each time a network device is attached to a cable, a phenomenon called insertion loss occurs, that is, each physical connection adds to the attenuation of signals on a capable segment. So therefore, it is necessary to restrict the maximum number of devices so the signals that traverse it are kept clean and strong enough to remain intelligible to all devices. So this will be the formula. The true maximum is equals to rated maximum minus the insertion loss. Okay, next is the interference susceptibility. Each type of cable is more or less susceptible to other signals present in the environment, where such interference may be electromagnetic, called the electromagnetic interference or the EMI, or may result from other broadcast signals, called the radio frequency interference or the RFI. So here are the four levels of susceptibility: the none, low, moderate, and high. Okay, next will be the connection hardware. Every type of cable has associated connectors that influence the kinds of hardware to which the cable can connect and affect the cost of the resulting network. This chapter also describes whether such connectors are easy to attach if attaching them requires specialized equipment, and whether building such cables should be left to professionals. Next is the cable grade. Building and fire codes both include specific cabling requirements. Usually, aim at the combustibility and toxicity of the cladding, the sheet material, and insulation that cover most cable. Polyvinyl chloride, or the PVC, covers the cheapest and most common cables. For examples, the 120 V cord found on most lamps and other household appliances. So the plenum is commonly used to aid air circulation for heating and cooling. Any cables used in the space must be plenum rated, which typically means they are coated with Teflon because of the materials, low combustibility, and the relatively non-toxic fumes it produces when burned. Okay, the other types of the general cable characteristics is the bend radius. Although some types of cabling are less prone to damage from bending than others, bending many types of beyond prescribed bend radius damages or destroy them. This is particularly true of the most expensive types of cable. For networks, this means primarily that fiber optic and heavy duty coaxial cables must be treated with care. Next, material cost. Each type of cable has an associated cost per unit length. This is a good way to compare cables of the same type to one another. However, it's important to understand the building fire codes may prohibit the use of cheaper cables in many instances, and that the cost of the cable itself is usually less than half the cost of a total installation. So the last types of the general cable characteristics will be the installation cost. Labor auxiliary equipment can easily cost more than the cable when installing a network. That's why it's important to cost out the design, installation, and troubleshooting for cabling, sometimes called the cable plant, as well as to budget for the necessary cabling, connectors, wool plates, patch panels, or punch down blocks, and other items required for a complete function network. Okay, the next topic is the baseband and broadband transmission. So let's go first for the baseband transmission. Uses a digital encoding scheme at a single fixed frequency where signals take in the form of discrete pulses of electricity or light. In a baseband system, the entire bandwidth of the cable is used to transmit a single data signal. This means that baseband systems use only one channel on which all devices attached to the cable can communicate. Baseband transmission also limits any single cable strand to half duplex transmission, where only one sender consumes the entire cable's bandwidth. Full duplex implementations that use baseband transmission must therefore use two strands of cable and two network interfaces for each device, one for sending data, the other for receiving data. As a signal travels along a network cable, its strength decreases as the distance from the signal transmitter increases. Likewise, the degree of distortion also increases as the distance from transmitter increases. Baseband systems such as Ethernet use special devices called repeaters that receive incoming signals on one cable segment and refresh them before retransmitting them on another cable segment. That's why, that's way they can restore the signal to its original strength and quality before shipping it out on another cable, thereby extending the span that a network can cover. So next will be the broadband transmission. Systems use a different kind of signaling to transmit information across a cable. Instead of digital pulses, broadband systems use analog techniques to encode information across a continuous range of values rather than using the binary zeros and ones that characterize digital data in the baseband environment. Broadband signals move across the medium in the form of continuous electromagnetic or optical waves rather than in discrete pulses. Where the cabling supports sufficient bandwidth, multiple analog transmission channels may operate on a single broadband cable. This capability permits your cable television company to send a large number of television channels across a single wire. Because of the differences between analog and digital signaling technologies, broadband cable segments are interlinked with devices called the amplifiers that detect weak signals, strengthen those signals, and rebroadcast them. So these are the two types of the broadband transmission. The mid split broadband and the dual cable broadband. In mid split broadband, it uses a single cable but divides the bandwidth into channels, each on a different frequency. Here, one channel transmits and the other receives network communications. Next is the dual cable broadband. Use two cables. Each computer or network device must connect to both simultaneously. Here, one cable transmits and the other receives network communications. We're down to the simultaneous 3 to 1 baseband versus broadband communication. Traditionally, broadband systems offered higher bandwidths than baseband systems. For example, original Ethernet cable supports 10 Mbps, but ordinary TV cable supports the equivalent of 250 Mbps. Today, higher speed networking alternatives for both technologies blur the distinction. But broadband systems remain generally more expensive than baseband systems of comparable bandwidth because of the broad and systems need for multiple cables or channels and for tuners and amplifiers for each channel. The importance of bandwidth. The trend networking is to offer more complex, more comprehensive, and more powerful services, including services such as a real-time video teleconferencing, voice-only networking services, streaming video and audio, and other high bandwidth applications. Thus, a set of parallel trends in networking is for technologies to deliver ever higher amounts of bandwidth, and for application developers to build software that requires more bandwidth to operate. Users demand access to such applications and are increasing their use of existing network applications, consuming still more bandwidth. And that's all for my report. Thank you.
Hello everyone, I am Lourdine Von L Cataluña and I am going to report about coaxial cable, twisted pair cable, and fiber optic cable. Coaxial cable is often called as coax for short. It is a type of transmission line used to carry high-frequency electrical signals with low losses. Therefore, it is used in such applications as telephone trunk lines, broadband internet networking cables, high-speed computer data buses, cable television signals, and connecting radio transmitters and receivers to their antennas. So this is a coaxial cable looks like. Coaxial cable has a central insulated conductor which may be a solid wire or stranded. It is called conducting core. Then the conducting core covered with insulator which is called PVC or Teflon. It is then enclosed in a conducting layer which is usually a copper or aluminum mesh or sometimes with a solid metal sleeve. It is called braided shielding. Then, it is covered by an outer sheath or called a plastic jacket. The use of coaxial cable for Ethernet. The beginning of Ethernet are in coaxial cable. For years, Ethernet was run only over coaxial cable. Now there are two types of coaxial cable that is used for Ethernet. The thick coax or 10 base 5 and the thin coax or 10 base 2. Thick coax or 10 base 5 cable uses baseband transmission. The maximum data transfer speed is 10 Mbps. The maximum cable length is 500 meters. Thick coax has solid inner conductor that is rigid. It is also known as thick Ethernet or thicknet. While thin coax or 10 base 2 cable is thinner than thick coax. It has stranded inner conductor that is more flexible. It operates at 10 Mbps. It uses baseband transmission also, and the maximum cable length is 200 meters. Cables in the 10 base 2 system connect with B and C connectors. It is also known as thin Ethernet or THNet. Coaxial cable in cable modem applications. Standard cable with 75 ohm and RG59 that delivers cable television or CATV to million homes. It is also being used to deliver internet access to those homes. Cable modem internet access uses broadband technology to carry internet data signals and cable television channels on the same medium. Typical cable modem connections provide 256 kbps or 512 kbps bandwidth to home users. But the technology is capable of carrying data at much higher rates. Because cable modem uses a shared medium, the bandwidth that any one connects receives depend on the number of active connections in a particular neighborhood. The more active connections on a cable segment, the less total bandwidth any one modem will receive. This is what typical cable modem connections looks like. This one is the CATV cable from cable provider. And this one is the cable modem. This wire is called twisted pair patch cable to network card. It connects the cable modem to the computer and allows computer to have internet access. Other coaxial cable types. Coaxial cable works for other types of network besides Ethernet and CATV. Other applications for coax include ARCnet. ARCnet stands for Attached Resource Computing Network. ARCnet is an older networking technology developed at Data Point Corporation in the early 1980s. It supports bandwidth of only 2.5 Mbps, which probably explains why it has faded from use on modem networks. Twisted pair cable. Twisted pair is the simplest, oldest, and low-price cable medium. It is made up of two insulated copper wires, typically twisted around each other in a continuous spiral. The purpose of twisting the wires is to reduce electrical interference or noise from similar pairs close by. Twisted pairs can run several kilometers without amplification, but for longer distances, repeaters are needed. The most basic form of twisted pair wiring consists of one or more pairs of insulated strands of copper wire twisted around one another. These twists are important because they cause the magnetic field that form around a conducting wire to wrap around one another and improve twisted pairs' resistance to interference, while also limiting the influence of signals traveling on one wire over another called crosstalk. Twisted pair cable can be broadly categorized into the following two types: the unshielded twisted pair cable or UTP and the shielded twisted pair cable or STP. The first category of twisted pair is the unshielded twisted pair. So this is what unshielded twisted pair looks like. UTP is the most common type of twisted pair cable used in telecommunication networks. Also, UTP consists of two copper conductors each having their own insulating material like plastic intertwined with each other to cancel induced current. The Electronic Industries Association or EIA has developed categories for UTP. For Category 1, this category is used for voice transmission and it is basically used in telephone systems. It is efficient only for low-speed data transmission. For Category 2, this category is used for voice transmission, but it is equally preferred for data transmission of up to 4 Mbps. For Category 3, this category is used for data transmission because it provides high bandwidth to achieve high data transfer rates. It is standard cable for most telephone systems. For Category 4, it provides much higher data transfer rate of 16 Mbps. And lastly, for Category 5, it provides a maximum data transfer rate of 100 Mbps. For unshielded twisted pair, generally, RJ45 connects are used. The second category of twisted pair is the shielded twisted pair or STP. In STP, it has two twisted pairs, and it covers with foil shielding, and the foil shielding is covered with jacket or sheath. In STP cable, each pair of insulated conductors is encased in a metal shield to prevent crosstalk. The quality aspect of STP is same as the UTP, but the shield must be connected to ground. RJ45. Whether STP or UTP, twisted pair networks cabling most commonly employs RJ45 or registered jack. Shown below is the RJ45 connector and jack. Shown in the picture is the patch panel in the left and the punch-down block in the right. In this table, it shows the 10 base T Ethernet characteristics. So in the left side is the characteristics, and in the right side is the value. So the maximum cable length is 100 meters or 328 feet. The bandwidth is 10 Mbps. The band radius is twisted pair not subject to band radius limitations. Installation or maintenance. Easy to install, no need to reroute, and the most flexible. Cost. Least expensive of all cabling options. Connector type. RJ45 for device and wall plate connections. Security. Moderately susceptible to eavesdropping. Interference rating. Low and most susceptible of all electrical cable types. Fiber optic cable. It transmits digital signals in the form of pulses of light. Optical carriers are designated according to their transmission capacity. Fiber optic cable trades electrical pulses for their optical equivalents, which are pulses of light, because no electrical signals ever pass through the cable. Fiber optic media is as immune to interference as any medium can get. This also makes fiber optic cables highly secure. Shown below is the fiber optic cable diagram. This table shows fiber optic cable characteristics. So the maximum cable length is 2 km or 6,562 feet to 100 km or 62.14 miles. The bandwidth is 100 Mbps to 1 Gbps. Band radius 30 degrees or feet. Installation or maintenance. Difficult to install and reroute. It is sensitive to strain and bending. Cost. Most expensive of all cabling options. Connector type. There are several types like ST connector, SC connector, MIC connector, MTRJ connector, and SMA connector. Security. Not susceptible to eavesdropping. Interference rating. None. It has the least susceptible of all cable types.
Good day everyone. So I am Shela Mae R Daigon. So for the continuation of our report, I'll be discussing about cable selection criteria and crimping UTP. So cable selection criteria. Given so many different kinds of networking cable from which to choose, making a selection may seem daunting. But as you consider the following criteria for any particular network installation, the corresponding choices emerge. So the first criteria is the bandwidth. Higher bandwidth means more expensive cable and higher installation cost. The higher the bandwidth requirements, the more likely you are to use a less flexible, more heavily shielded, and if not fiber optic cable. And then second is budget. So how much money can you spend on cabling? Sometimes budget alone dictates a choice. Since all the cabling types had been ranked by cost, and it should be easy to tell what the budget dictates. And then third is the capacity. A network layout to separate light to moderate users from heavy users and to separate the backbone traffic from local user traffic generally a good idea. Such consideration can also affect cable choices and equipment requirements. And the next is the environmental consideration. Signal environment or security requirements can dictate cable choices regardless of the factors. So the higher either factor weighs, the more likely it comes that you choose fiber optic cable. And then we also need to consider the placement. Requirements for cable flexibility, access, routing also heavily weigh on cable selection, particularly where there are tight space or it's necessary to avoid obstacles. And then third is the span. Longer spans need more expensive, higher bandwidth cables if not more exotic options. Then local requirement. So local building and fire code officials must approve any new installation and should be consulted before installation decisions are made. And then lastly is the existing cable plant. For a new installation, only previously listed criteria need to be considered. For an upgrade, the existing cable must be considered. For example, if some of the existing cable is to remain, is it compatible with the speeds and new equipment that are planned? And this table shows the comparison of general cable characteristics. And the next, I would be discussing about crimping UTP. So what is crimping? So crimping is joining two or more pieces of metal or other ductile material by deforming one or both of them to hold other. The band of deformity is called the crimp. And then crimping UTP is for your camera system to work properly. The UTP cables must be crimped correctly. Crimping a UTP, this requires an Ethernet cable and RG45 connector. And this also requires a crimping tool. So how do you crimp UTP? So first step is strip the cable and unwind the wires. Use the sharp part of the crimping tools to strip the cable about 2 cm long. The easy way to do this is to press the crimping tool lightly together and turn it around the cable so that the tool cuts open the cable sheath all around. When you push the cable sheath down, you can see 4 pairs of twisted wires. Wrap these wires apart so that you have 8 wires in front of you. And then check that the wire have not been damaged when stripping the outside of the cable. And then second step is bring the wires in the correct order and cut the wires straight. So bring the wires in order shown below and cut them straight off with the crimping pliers about 13 millimeters long. And then third is push the wires into the connector. So hold the connector so that the clip is facing down. Push the wires into the connector in exactly the right order, right to the end so that the wires lie under the copper contacts. And now there is about 8 millimeters of the jacketed cable in the connector. This is important so that the connector does not move after crimping. And then lastly is squeeze the connector. So push the plug and cable into the crimping tool and press the tool together twice. Then slide the connector on the other side of the crimping tool. The wire should now be stuck under the copper contacts and the cable should be firmly clamped. You can no longer pull the cable out of the connector, and then repeat the process on the other end of the cable.